In this video we're going to consider another use of completing the square. And this can happen when you're asked to solve a quadratic equation. Now there are three methods for solving quadratic equations. The first and most basic method, the one that you should turn to first, your first port of call, your first thought, is factorising, putting it probably into double brackets, equal to 0, and working from there. The second method is using the quadratic formula. The third method, completing the square, we're going to look at today. For what it's worth, completing the square is actually identical to using the quadratic formula. The quadratic formula has been arranged for you so that you don't need to complete the square. But sometimes you'll be told to. You'll be told to use this method and then you have no choice. So you do need to understand it. It goes something like this. X minus 5 all squared. Take 3, but we must not lose that equals naught. It is important. Now, this isn't right as it stands. X squared minus 5x minus another 5x plus 25. We don't want the plus 25 that's hiding in there. We remove it. And if we simplify that left-hand side, we get x minus 5 all squared minus 28 equals naught. We can now start changing the subject, rearranging to make x equal to everything else. So x minus 5 all squared equals 28. That's because, of course, we've added 28 to each side. Now, we square root. Square root undoes or reverses the square, and the square root of 28 we're not going to reach for the calculator. We're going to leave it as a surd root 28. And it's here that people will often make a mistake. If I ask what the square root of 9 is, most people will just say 3. And that's fair enough. 3 squared is 9. But positive 3 is not the only answer. Positive 3 is not the only number that when you square it, it gives you positive 9. Negative 3 achieves that as well. And so the correct answer for the square root of 9 is actually plus or minus 3. There are two possibilities. And for the same reason, the square root of 28 is plus or minus 28. This is why the quadratic formula has a plus or minus symbol in it. We can then add 5 to each side. And so we discover that x equals 5 plus or minus the square root of 28. And I'm going to leave it like that because it's exact, it's nice and precise, and there's no real need to turn it into a decimal. So you can solve an equation, a quadratic equation, by completing the square. The last example I want to look at, a bit more complicated. Find the centre and radius of this circle. Well, what we can do is we can rewrite this x squared plus 4x, so pull all of the x terms together, plus y squared minus 6y, gather those all together. Let's leave the minus 12 sitting out there, equals 0. And now we can complete the square on the x squared plus 4x part, and we can also complete the square on the y squared minus 6y part. Let's see what happens. X plus 2 all squared. There's a positive 4 in there that I don't want. Plus y minus 3 all squared. There's a positive 9 in there that I don't want. That negative 12 was part of the original question, it's still there. And so we can write the original equation like this. X plus 2 all squared plus y minus 3 all squared minus, now, negative 4, take 9, take 12 is negative 25. So what we have is x plus 2 all squared plus y minus 3 all squared equals, if we add 25 to both sides, equals 25. Now, in the same way that a straight line always has equation y equals mx plus c, and in the same way that a quadratic always has equation y equals ax squared plus bx plus c, so a circle always has equation x plus a all squared plus, I should have put a minus in there, x minus a all squared plus y minus b all squared equals r squared. That's the standard equation for a circle. And the centre of such a circle is always a comma b, and the radius is r. So we can see here that we have a circle centred at -2, comma 3, with a radius of 5. And that's that question done.